Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information. The Voyager 1 space probe, launched by NASA in 1977, has long been one of the most incredible achievements in human exploration. Over the decades, it has given us invaluable data about the farthest reaches of our solar system and beyond. In a surprising and groundbreaking development, renowned astrophysicist Neil deGrasse Tyson recently announced that Voyager 1 has detected over 500 previously unknown objects passing by in space. This revelation opens the door to countless questions and possibilities, sending ripples of excitement throughout the scientific community. Before we start, hit the like and subscribe buttons for more exclusive news. Voyager 1 is currently located more than 14 billion miles from Earth, traveling through the outermost layers of the heliosphere, the region of space influenced by the solar wind and magnetic field of the Sun. In 2012, it made history by becoming the first human-made object to enter interstellar space. However, its journey is far from over. The detection of these 500 unknown objects signals the vast and largely unexplored nature of the universe that lies beyond the familiar confines of our solar system. As these objects passed by the probe, they provided data that has stunned researchers, revealing not only their presence but also information about their movement, composition, and behavior. The discovery of these objects is significant for several reasons. First and foremost, it challenges previous notions of interstellar space as an empty, desolate void. Traditionally, the space between stars, referred to as the interstellar medium, has been thought to consist mainly of gas and dust particles, with occasional rogue asteroids or comets. However, the sheer number of objects detected suggests a far more dynamic and populated environment. While some of these objects may be small, others could potentially be larger than anything we've encountered before, and each one holds the potential to teach us more about the formation and evolution of celestial bodies. This detection not only expands our understanding of what lies beyond the solar system, but also hints at the possibility of many more undiscovered phenomena in the vast reaches of interstellar space. Scientists are currently working to analyze the data transmitted by Voyager 1 to classify these objects more accurately. They are particularly interested in understanding their origin. Could they be remnants from ancient star systems, rogue planets expelled from their home solar systems, or something entirely unknown to modern science? These questions drive the ongoing analysis and create a sense of urgency in unlocking the mysteries that Voyager 1 has brought to light. One of the most thrilling implications of this discovery is how it might reshape our understanding of the formation of stars and planets. If these objects turn out to be planetary bodies or the remains of planets, they could provide clues about the processes that lead to planet formation in other star systems. Additionally, the detection of objects in regions where we previously thought there was little to no material might force us to reconsider our models of how interstellar space operates. The possibility that rogue planets, objects that once orbited stars but have since been ejected, might exist in greater numbers than previously believed adds another layer of intrigue to this finding. Neil deGrasse Tyson's announcement also hints at a broader question regarding the nature of our universe. Are we only just beginning to understand the complexity of interstellar space? For years, space exploration focused on our solar system, its planets, moons, and nearby asteroids. However, as Voyager 1 moves deeper into the unknown, it's becoming increasingly clear that interstellar space is not a vast emptiness but a thriving ecosystem filled with objects and phenomena waiting to be discovered. This revelation encourages a shift in how we approach space exploration. Instead of focusing only on our solar system and nearby stars, we may need to broaden our scope to include the vast stretches of interstellar space. Voyager 1's data could lead to further technological advancements in space exploration. With the detection of these unknown objects, scientists are already discussing the possibility of designing future probes equipped with more advanced sensors that can study these objects in greater detail. The ability to capture and analyze interstellar objects opens up a new frontier in space exploration. The more we learn from these encounters, the better prepared we will be to venture deeper into space beyond the limits of our current technology. Neil deGrasse Tyson, in his typical style, emphasizes that while Voyager 1's discoveries are groundbreaking, they are only the beginning of what could be a new era of exploration. Another important factor to consider is the potential role these objects could play in answering fundamental questions about the universe's origins. If some of these objects are remnants from the early days of the universe, they could offer insights into how the cosmos developed after the Big Bang. There may even be evidence of how early star systems formed, collided, and changed over billions of years. By studying the chemical composition and physical properties of these objects, scientists can trace back their origins and compare them with other known objects in space. This comparative analysis could provide a more cohesive picture of the universe's evolutionary history. Voyager 1's ability to detect these objects also presents new challenges. For instance, what is the nature of the forces that are propelling these objects through space? Are they moving through interstellar space due to the gravitational pull of nearby star systems, or are there other, as yet undiscovered forces at play? Moreover, the data from Voyager 1 shows that these objects are not static, but are moving at various speeds and in different directions. Understanding the mechanics of how these objects travel through space could revolutionize our understanding of celestial mechanics and the forces that govern the movement of objects outside our solar system. One of the more speculative ideas that arises from this discovery is whether any of these objects could harbor life or the building blocks of life. While this is highly speculative, it's not entirely outside the realm of possibility. Scientists have long theorized that rogue planets, planetary bodies that have been ejected from their star systems, might be capable of supporting life under certain conditions. If some of these 500 objects are planets or large celestial bodies, there could be a small chance that they possess conditions suitable for life. Even if these objects do not harbor life themselves, they could contain organic molecules, which are essentially building blocks for life as we know it. This detection also raises questions about how common such objects are throughout the galaxy and beyond. If Voyager 1, which has a relatively small observational range in the vastness of space, can detect 500 objects in its vicinity, it stands to reason that there could be millions or even billions of similar objects scattered across the Milky Way galaxy. This would suggest that the galaxy is far more crowded and diverse than we previously thought. The implications of this are profound, especially when considering the future of space travel. If space is filled with such objects, future missions may need to account for the potential risks and opportunities they present. Neil deGrasse Tyson's announcement has also sparked discussions about the nature of the unknown. It is a reminder that despite our technological advancements and the wealth of knowledge we've gained about the universe, there is still so much that we don't know. Voyager 1 has once again proven to be a pioneer, pushing the boundaries of human knowledge and showing us that the universe is filled with surprises. These unknown objects represent the frontier of human curiosity, each one a puzzle waiting to be solved. The discovery also has philosophical implications. For centuries, humans have looked to the stars, wondering what lies beyond. The idea of unknown objects floating through interstellar space brings a sense of wonder and awe, reminding us of the vastness of the universe and our relatively small place within it. Tyson, a master at communicating the awe-inspiring aspects of science, emphasizes that discoveries like these fuel our sense of exploration and our desire to understand the cosmos. This revelation by Neil deGrasse Tyson might also influence how we think about the future of humanity in space. As we look toward potential human exploration of deep space, it's crucial to understand the environment we will be venturing into. If space is not as empty as we once thought, future missions will need to account for the presence of these objects. This could affect everything from navigation to the design. The discovery made by Voyager 1 has profound implications for spacecraft design, particularly in terms of enhanced shielding and detection systems to avoid collisions with unknown objects. If these objects are remnants of star systems, they may contain materials that could provide insights into the conditions necessary for life to develop elsewhere in the universe. Even if they are not directly related to life, they could still contain valuable information about the diversity of chemical elements and compounds present in the universe. By analyzing these materials, scientists could better understand the potential for life beyond Earth and the types of environments that might support it. Voyager 1's detection of 500 unknown objects passing by in space is more than just a scientific revelation. It's a reminder of how much we still have to learn about the universe. Each of these objects presents an opportunity to challenge and refine our understanding of interstellar space, which until now has been largely theoretical. Beyond the influence of our sun, these objects raise numerous questions that push scientists to rethink assumptions about everything from the density of interstellar space to the origins of these celestial bodies. The exact nature of these objects remains mysterious, but their presence signals that interstellar space is far more active and complex than previously believed. The term object could refer to anything from small chunks of space debris to rogue planets or even celestial bodies that have no precedent. These objects likely vary in size, composition, and origin, with some potentially being interstellar dust clumps and others remnants of shattered planets or moons. Detecting 500 objects in such a short observational window suggests that there may be an astronomical number of similar objects still to be found. The discovery forces us to revisit our models of how the galaxy, and by extension the universe, functions on a macroscopic scale. Previously, scientists believed interstellar space to be a sparse, nearly empty region filled only with gas and occasional cosmic dust. However, Voyager 1's detection paints a different picture, suggesting that space may be filled with unknown bodies, indicating that the universe's fabric is far more intricate than we once thought. This could significantly impact models of galactic formation, interstellar travel, and even the long-term stability of the universe. These objects provoke intriguing questions about their interaction with larger cosmic forces. How do gravitational tides from nearby star systems or black holes influence their trajectories? Could dark matter, the elusive substance making up a significant portion of the universe's mass, be involved in their movement? Until now, we've had limited observational data from interstellar space, so scientists relied on theoretical models to predict how matter behaves in these distant regions. Now, with the discovery of these objects, they have concrete data to either confirm or upend current models of interstellar dynamics. Additionally, these objects provide a fascinating glimpse into the history of our galaxy. Some may have originated in distant star systems before being flung into interstellar space through gravitational interactions or cataclysmic events like supernovae. Others might be relics of ancient planetary systems that no longer exist, leaving only these fragments to drift through space. Understanding their age and composition could offer invaluable insights into the processes that have shaped the Milky Way over its 13 billion-year history. The data Voyager 1 has sent back about these unknown objects is still being analyzed, but the implications are already profound. Each object could represent a chapter in the untold story of our galaxy, and understanding their nature could provide a timeline of events stretching back to the Milky Way's very beginnings. This could, in turn, help scientists answer long-standing questions about how galaxies evolve and how stars, planets, and other celestial bodies are distributed across interstellar space. Neil deGrasse Tyson's announcement serves as a powerful reminder of how little we know about the distant reaches of space, especially regarding the variety and composition of matter beyond our solar system. The discovery of these unknown objects suggests that the void between stars may not be as empty as we once thought. Instead, it could be teeming with debris from ancient star systems, failed planets, or other celestial bodies yet to be classified. This discovery could spur new fields of study focused on understanding these interstellar wanderers. One particularly exciting possibility is that these objects could reveal new information about the chemical makeup of the universe. If some of the detected bodies are remnants of destroyed star systems, their composition could offer clues about elemental distribution in the universe, shedding light on how various elements formed and were distributed throughout space. Voyager 1's ability to analyze these objects could lead to breakthroughs in understanding how the building blocks of matter are spread across the galaxy and what that tells us about cosmic evolution. The discovery also has potential implications for the search for extraterrestrial life. Although it's a long shot, some of these objects could carry organic compounds or other materials suggesting that conditions necessary for life might exist elsewhere in the universe. While it's unlikely that life could survive on rogue planets or drifting celestial bodies in interstellar space, the detection of life's building blocks, such as amino acids or complex organic molecules, could reignite the search for life beyond Earth. If these objects are fragments of former planets or moons, they might contain remnants of atmospheres or environments that once supported life. This discovery also redefines the future of space exploration. As humans develop plans for deep space missions, the detection of unknown objects in interstellar space becomes crucial. Future spacecraft designed to explore regions beyond our solar system will need sensors capable of detecting and avoiding these objects. The potential for spacecraft to encounter unknown debris or rogue bodies adds a new layer of complexity to interstellar travel, and spacecraft for deep space missions will need to account for these objects to ensure safe passage. Voyager 1's discovery may also impact the design of future space probes and exploratory missions. Although Voyager 1 was not specifically designed to detect or analyze interstellar objects, it has made one of the most significant discoveries in modern space exploration. This could prompt NASA and other space agencies to develop probes with enhanced detection capabilities for future missions, equipped with advanced sensors to analyze the composition, trajectory, and origin of unknown objects. In the context of long-term space exploration, these unknown objects may even become targets for future study. As human technology advances, we may one day be able to send missions to study these objects up close, possibly landing probes on larger bodies to analyze their surface composition and history. These objects could represent the first step toward a new era of exploration, one that extends beyond our solar system and into the broader galaxy. This discovery also challenges our understanding of celestial mechanics. If these objects are remnants of planetary systems or rogue planets, they could provide valuable data on how planets form, evolve, and eventually die. By studying their trajectories and properties, scientists may gain new insights into the processes that govern planetary formation and destruction, potentially leading to a more comprehensive theory of how planets, moons, and other celestial bodies are created and what happens when they are ejected from their home star systems. In addition to these significant insights, the detection of these objects also raises important questions about the forces at play in interstellar space. The discovery offers new data about gravity, dark matter, and other cosmic forces that influence how these objects drift through the galaxy, further expanding our knowledge of the universe's complex mechanics. Through interstellar space, their movements could offer clues about the gravitational interactions between stars, galaxies, and other massive bodies. Some of these objects may be influenced by the gravitational pull of nearby stars or even black holes, and their trajectories could provide valuable data for scientists studying the distribution of mass in the galaxy. This, in turn, could lead to new discoveries about the structure of the universe and the forces that govern its expansion and evolution. Neil deGrasse Tyson's revelation has also sparked a renewed interest in the broader question of what lies beyond the observable universe. While the discovery of these objects is significant on its own, it also hints at the possibility of even more unknown phenomena waiting to be discovered in the farthest reaches of space. This could be just the beginning of a new era in space exploration, one in which scientists are able to probe deeper into the mysteries of the cosmos and uncover new insights about the nature of the universe itself. The unknown objects detected by Voyager 1 also raise important questions about the limits of human knowledge. For centuries, humans have sought to understand the universe through observation, experimentation, and theoretical modeling. However, the discovery of these objects is a reminder that the universe is far more complex than we can currently comprehend. It challenges the assumption that we have a firm grasp on the basic properties of space and forces us to reconsider what we know about the distribution of matter and energy across the cosmos. Voyager 1's detection of these objects is not only a testament to the probe's technological prowess, but also a symbol of human ingenuity and our insatiable curiosity. Launched more than 4 decades ago, Voyager 1 has outlived its original mission and continues to provide groundbreaking data that reshapes our understanding of the universe. This discovery is a reminder of the importance of long-term space exploration and the value of investing in missions that push the boundaries of human knowledge. One of the most significant aspects of the discovery of these objects is how it calls into question the traditional understanding of interstellar space. Until now, we've assumed that the space between stars, known as the interstellar medium, was primarily filled with low-density gases and occasional dust particles. The presence of so many detectable objects challenges this perception and introduces a new category of celestial bodies that were previously unseen. While scientists had hypothesized about rogue planets and other massive bodies drifting in interstellar space, Voyager 1's detection of such a large number of smaller objects, ones that do not fit into the established categories of stars, planets, or asteroids, requires us to develop entirely new models of the interstellar environment. It's not just the quantity of these objects that's surprising, but also the diversity they represent. Preliminary data from Voyager 1 suggests that these objects are not homogeneous but vary widely in size, composition, and motion. This diversity could suggest a number of different origins for these objects. Some may have been ejected from their home star systems by gravitational interactions, while others could be debris from cataclysmic events like supernovae or collisions between planets and moons. There may even be objects that formed in interstellar space itself, coalescing from the dust and gas that drift between stars. Each of these scenarios offers tantalizing clues about the processes that govern the creation and destruction of celestial bodies across the universe. Moreover, the movement patterns of these objects could reveal crucial information about how interstellar space operates on both a large and small scale. As Voyager 1 continues to study the motion of these objects, scientists are looking for patterns that could suggest the influence of unseen forces or structures in space. For example, if these objects are moving in ways that can't be explained by known gravitational forces, it could provide evidence for the existence of dark matter or other exotic forms of energy. Dark matter, which makes up about 27% of the universe's mass, remains one of the greatest mysteries in modern physics. If these unknown objects are interacting with dark matter, it could give scientists a new way to study this elusive substance. One of the more speculative yet compelling ideas raised by this discovery is the possibility that these objects could offer new insights into the behavior of space-time itself. The detection of so many unknown objects in interstellar space, combined with their varied trajectories, could suggest that space-time is not as uniform or predictable as we've long believed. Just as the discovery of gravitational waves revolutionized our understanding of how massive objects interact across space, the study of these unknown objects might reveal new information about the nature of space-time on a cosmic scale. If these objects are moving in ways that challenge our understanding of gravitational forces, it might point to distortions in space-time that we have yet to account for. Equally intriguing is the potential for these objects to change how we view the early history of the universe. If some of these bodies are remnants from the early days of galaxy formation, they could contain information about the conditions that existed shortly after the Big Bang. Voyager 1's data might help scientists identify elements or compounds within these objects that can't be found elsewhere, providing a rare window into a period of the universe's history that remains poorly understood. These findings could allow researchers to construct more accurate models of how galaxies and star systems formed, evolved, and collapsed over billions of years. On a more granular level, the composition of these objects could help scientists understand how the elements necessary for life are distributed throughout the universe. If any of these objects contain organic molecules or other precursors to life, it would provide strong evidence that the building blocks of life are common throughout the cosmos. This would have profound implications for the search for extraterrestrial life. It would suggest that life, or at least the conditions necessary for life, could be more common than we once thought. While it's highly unlikely that these objects themselves harbor life, their composition could offer clues about how life might form in the hostile environment of interstellar space or on rogue planets that have been ejected from their home star systems. Another major implication of this discovery is its potential impact on the future of space travel. As humanity sets its sights on interstellar exploration, the presence of so many unknown objects in interstellar space poses both challenges and opportunities. On the one hand, these objects represent potential hazards for spacecraft traveling at high speeds through space. Even a small object moving at thousands of miles per hour could cause catastrophic damage to a spacecraft. This means that future spacecraft designed for interstellar travel will need to be equipped with advanced detection and avoidance systems to navigate safely through the debris-strewn environment of interstellar space. On the other hand, these objects also represent potential opportunities for future exploration. Some of the larger bodies detected by Voyager 1 could be ideal candidates for future missions. If these objects turn out to be rogue planets or large asteroids, they could serve as way stations or targets for scientific exploration. They might even harbor resources such as water, ice, or minerals that could be useful for future space missions. The presence of so many objects in interstellar space could make it easier for future explorers to island hop between celestial bodies, reducing the need to carry large amounts of fuel and supplies for long-distance missions. This discovery also invites us to rethink our definition of planets and other celestial objects. As our understanding of the universe expands, it's becoming increasingly clear that our traditional categories, planets, moons, asteroids, comets, may not be sufficient to describe the variety of objects that exist in space. Some of the objects detected by Voyager may first not fit neatly into any of these categories. This raises the possibility that we need to develop new terminology and classifications to describe the objects we're discovering. This is reminiscent of the debate over the status of Pluto, which was reclassified as a dwarf planet in 2006 after astronomers discovered other objects in the Kuiper Belt that were similar in size and composition. The presence of these unknown objects also has important implications for our understanding of planetary systems. If many of these objects are rogue planets or remnants of destroyed planets, it could suggest that planetary systems are far less stable than we once believed. Traditional models of planetary formation suggest that planets form from the dust and gas left over after a star is born, and that they generally remain in orbit around their parent star for billions of years. However, the detection of so many objects in interstellar space suggests that this is not always the case. It's possible that planetary systems are much more dynamic, with planets and other objects being ejected from their systems more frequently than we previously thought. This discovery could also change our understanding of the long-term evolution of planetary systems. If planets can be ejected from their systems and become rogue objects drifting through interstellar space, it raises questions about the ultimate fate of planetary systems like our own. Could Earth one day be ejected from the solar system and become a rogue planet? While this is unlikely to happen in the near future, the discovery of so many rogue objects suggests that planetary systems are not as permanent as we might have assumed. Moreover, this revelation raises important questions about the fate of these rogue objects once they've been ejected from their parent systems. Where do they go? Do they eventually become captured by other star systems? Or do they continue drifting through space indefinitely? Some of the objects detected by Voyager may first have been ejected from their parent systems billions of years ago and have been drifting through space ever since. Others may have only recently been ejected and are still relatively close to their parent stars. Understanding the long-term fate of these objects could provide valuable insights into the dynamics of planetary systems and the forces that shape their evolution. As scientists continue to analyze the data from Voyager 1, one of the most pressing questions they face is whether these objects represent a common phenomenon throughout the galaxy or if they are unique to the region of space that Voyager 1 is currently exploring. If these objects are common throughout the galaxy, it would suggest that interstellar space is much more crowded than we previously thought. This would have important implications for future space missions, as well as for our understanding of the distribution of matter in the galaxy. If, on the other hand, these objects are unique to the region of space that Voyager 1 is currently exploring, it would raise important questions about what makes this region of space different from others. One of the most intriguing possibilities raised by this discovery is that these objects could provide clues about the presence of other star systems or galaxies that we have not yet detected. If some of these objects were ejected from star systems that are too far away or too faint to be observed with current technology, they could serve as breadcrumbs leading us to the discovery of new star systems or even entire galaxies. This would be an incredible breakthrough, as it would allow us to map regions of space that are currently beyond the reach of our telescopes. This discovery also has implications for our understanding of the boundary between interstellar space and galactic space. Traditionally, interstellar space has been defined as the region between stars, while galactic space refers to the space within galaxies. However, the detection of so many objects in interstellar space blurs the line between these two regions. If these objects are remnants of destroyed star systems or planets, it suggests that the boundary between interstellar and galactic space is not as clear-cut as we once thought. Instead, it may be more accurate to think of interstellar space as a continuum, with objects drifting between galaxies and star systems over billions of years. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us what you think these objects could be? We want to hear from you. Thank you for watching, and see you next time.